Hi, my name is Jake Erley, and I will be presenting problem number 73 from page 882 in the textbook. The question is asking to use data from Appendix 2b to calculate the equilibrium constants at 25 degrees Celsius for each reaction. Below are the two reactions that we'll be determining. Now, to better understand the question, we have to find out exactly what it is asking. And it is asking us to calculate the equilibrium constants at 25 degrees Celsius for each reaction. Now, we're going to have to use units and equations here, so we want to evaluate them to better understand the problem. In this case, we will be using joules, moles, Kelvin, kilojoules, and Celsius. The equations we'll be using are the delta G reaction equation, which is equal to the number of moles of the product multiplied by the delta G of the product, subtracted by the number of moles of the reactant multiplied by the delta G of the reactant. And the other equation we'll be using is the thermodynamic equilibrium equation, which is equal to e to the negative delta G, which we would find here, divided by the RT. R is a constant. In this case, we'll use 8.3145, which differs from others who may use 8.314, and temperature, which will be in Kelvin. We're going to look at the first reaction here. Now, before anything, we want to determine whether or not it is balanced, which it is. So we can hop right into step 1, which is determining the delta G using our equation that we just went over, which is the delta G of the reaction. From Appendix 2b, I determined the delta G for carbon dioxide, carbon monoxide, and oxygen. And I plugged it right into the delta G reaction equation. Here, I have 2 moles of carbon dioxide multiplied by the delta G of carbon dioxide, subtracted from the number of moles of carbon monoxide multiplied by the delta G of carbon monoxide, added to the delta G of oxygen. And I got an answer of negative 514.4 kilojoules per mole. Next, I want to use the thermodynamic equilibrium equation to determine our answer. However, before that, we need to make sure all of our units are in unison. In this case, R is in joules and Kelvin. So we have to convert delta G from kilojoules to joules and temperature from degrees Celsius to Kelvin. From there, it's as simple as plugging it right into our calculator and obtaining an answer of 1.48 times 10 to the 90. Again, unitless because all of the units cancel. Our next reaction that we'll be evaluating is also balanced. So we can hop right into step 1 and determine the delta G of the reaction using our delta G of the reaction equation. Here, we found from the appendix our delta G for hydrogen, disulfur, and dihydrogen sulfide. After that, it's as easy as plugging it into our delta G reaction, where we have here our disulfur, our hydrogen, and our dihydrogen sulfide, which gave us an answer of 146.5 kilojoules per mole. After that, similarly to the last one, all we have to do is convert to joules and Kelvin, simply plug it in, and we obtain an answer of 2.10 times 10 to the negative 26, which this answer may differ plus or minus 0.01 because of the R value we used. However, it's not significant at all. I'd like to thank you very much for watching, and today, as a reminder, we found the equilibrium constant by using the thermodynamic equilibrium equation.